So aside from the hiss, which is actually quite difficult to talk over with everything set halfway. Oh, now it's gone away. Alright, so hiss now gone. Problem solved, right? It's sounding reasonably strong in the clean mode. A little bit of overdrive there, just starting to break up in half power mode. Alright, so let's go through the controls. We'll just test them one by one. Okay, treble seems to be working. Bass control's pretty subtle, but it's working. Mid control's working. Master control's working okay. Pull for deep. Seems to work. Pull for treble shift. Seems to do nothing. Pull for bass shift. Seems to be working. Okay, for pull for rhythm 2. Seems to sound alright. Pull for lead. Alright, so that pot's pretty dirty. So it's got your typical sort of mushy, sort of like a pushed Fender overdrive sound, which is, I guess, the genesis of Mesa in the first place with hot-rodded Princetons. But things get pretty funky when you start adjusting the lead controls. Lead master on 10, no signal. Lead master on 0, no signal. That's a mod fuck up, which we showed earlier. Now reverb. Now I've got a reverb tank plugged in, but all it seems to do is add fuzz. So yeah, this is all a result of those retarded mods I showed you earlier. So all of that's got to come out. But overall, it's just sort of... So with that reverb on, it's that mod, whatever it is, it doesn't make any sense at all. We're not getting any reverbs, probably no send or return. So all of that's got to come out. And we're going to return it back to stock as mentioned earlier. Because in my book, this doesn't sound very good. So let's just test the EQ, check that all the inductors are working. Yep, they all seem to be good. And it works in full power mode too, and that's gone up to about 114 watts idle, which is about what you'd expect. Quite a bit of hum there in the background. Quite a bit of hum when you bring up the master. A lot of hiss added when you bring up the reverb, and that weird behaviour with the lead master. So anyway, enough faffing about. Let's power this thing down, discharge it, and we'll get our hands dirty. Oh, one other funny thing I wanted to show you is the Mesa fart. So this is part of the solid state circuitry in it associated with the EQ there. When you power it off, it just, as the rails collapse, goes through a state of uncertainty there where there's a slight oscillation for a second and it sounds like a Mesa fart. Wait for it. Wait for it. There it is. Everyone gets concerned by that, but it's just part of the design. You can get around that with actual design work. I'm not going to get into that right now, but there's ways to get around just unknown states like that as circuits power up and down. Got 4 Sovtecs there, 6L6s going into the original ceramic sockets, which look to be in good condition still, so that's good. Got our 2 foot switch jacks there, which look good. Got our Texture valve designators there, which I think is the case from the factory on all of them. Got our reverb sockets there. You got this funky little block of wood, which actually is a factory thing to try and stop vibration, but now it just exacerbates it because it's loose. This pissy metal that they make the transformer covers out, it just bends. Silicon a chunk of wood in there as a factory fix. Tells you all that you need to know about Mesa. And there's our cable tie holding on our capacitor inside that someone's installed at some point. And there's our additional valve, which is a, who knows, because it's got no markings. That's going into an old Bakelite socket there that you've used. Makes me think that maybe it was either installed with new old stock parts or installed quite some time ago when that was a new part. Oh, and before I forget, champions, one important thing if you're working on amps such as these, make sure you don't do it on an empty stomach, because you do not want one iota of hangriness to be a factor. I think a car just beeped at me. A factor in working on these things. You want to be relaxed and calm, preferably caffeinated, be it through tea or coffee or, you know, mother energy drinks, whatever it takes, bro. Alright, let's start the snippety doodah process. First thing I'll get rid of is this coax. Just going to leave a little bit of red on there so I know where they used to be, so I can maybe figure out what the hell they were thinking. Going to remove the components to this additional node, because that doesn't make sense. Cut out the supply lines to the filter capacitor up front at the right hand side of the chassis. It's very satisfying cutting things out. Cut the heater lines to the additional valve. Get rid of them. Almost forgot to get my old mate BOFA going there. Remove the filter caps. One big bank, they're all silicon together. Gives us some room to move now. You've got to be very careful with these holes, because Mesa circuit boards are pretty low quality. Very small pads, almost non-existent pads, so they're very easy to damage. And yes, they are low quality, despite what all the magazines and reviewers say. Are paid to say, I might add. So smaller components like resistors, at least on the early models, they tend not to fold the leads over on the bottom of the PCB, whereas later ones they folded them over at 90 degrees, so you really need to access the bottom of the PCB to change anything. That seemed to change around the Mark IV era. Now, where do we start here? Such a mess. Little bits of leads and stuff from previous mods and decisions made, and mine's changed. All the little stubs of wire left over from previous person changing their mind repeatedly. Previous person melted the PCB support standoffs with their soldering iron too, so I'll be replacing them. I've got some in stock. They tend to go very brittle anyway because they're a nylon in a high temperature amplifier, so I'll keep them on hand for replacement. I'll remove this cap. Don't know what it does yet, but I need to get to the bottom of it, where it is. Like I say, we'll be upgrading the phase inverter output coupling capacitors because they're underrated for the job. Alright, so we're making a bit of headway here. There's another little link wire down there, a little pissy, feels like 28, maybe 30 gauge wire. We'll place up with something a bit more skookum. I want to get rid of this ground bus because they're dumb and they short out on stuff. That's a factory thing. I want to get rid of the melted wiring. Alright, now we remove the main filter caps. Obviously I've already checked that these are discharged. What do you think I am, an idiot? Let's see if I can get underneath them with a razor blade to try and make the removal less traumatic. There's silicon to that little daughter board there. Sweet. One of my beard hairs, a little bit awkward. Even the silicon's starting to go hard. That's weird. It's like brittle. You can snap it. That's strange. It's just starting to get really, really old. I thought silicon lasted forever. I guess not. Just disconnect this HT wire to the standby switch for now, just so I can lift the board, get to the bottom side to inspect it and install the new caps. Be careful with these standoffs. I don't think I've got any quite this tall. And watch out for those inductors down there, because they can be a little bit delicate as well. Yep. Well, we've got that out of the way. We'll remove all this stuff down here. Looks like this was done quite a while ago, because again the silicon's gone like a yellow. It's not as brittle as the other stuff, but you can tell it's been there a long time. And I don't know how much that means, but the date code on the cap is 93. I've seen work done by certain techs that have installed like 15-20-year-old caps in a current job, so you never quite know. That doesn't definitively tell you when the job was done with these blokes. Let's try and cut away at that silicon if we can, just get under it. Once you get one side loose, the other side lets go. There we go. Mojo cap. Who wants to buy it? Alright, here's a new one. An interesting and ridiculous method at avoiding using some Loctite. Just using a bit of solder on the screw. It's great if you never want to undo it again. I was thinking that might just fly off as a blob, but it looks like they've actually got the screw hot enough for the solder to take to it. Luckily we don't have to undo that, because we probably have to cut them off. So now that additional valve's been removed, I can feel there's a really sharp burr on the bottom there. Significant size burr. So I think this was actually an aftermarket punch through, but they actually had a punch to do it with, because there's no signs of drilling here. Doesn't mean they didn't use their own knockout punch. So yeah, this is definitely not from the factory. Just testing the resistance of these balance resistors here, which is their primary job. People call them bleeders. They do bleed the cap as well, slowly, but their primary job is to make sure that each cap has the same voltage across it. It forms a voltage divider and makes sure that the center point is as close as possible to half dB+. So we've got 153.6K there and 161.9K there. And they're supposed to be both 150K. So it's within tolerance, but I might change them anyway. There's no tonal reason to have carbon comps there, and as they drift they'll get more and more out of balance. So we'll pop some 220s in there. So you've got 500 volts across the pair of them. They'll each be dissipating less than a third of a watt. So I've got a 1 watt in there, probably 2 watt actually, sorry. Heaps of margin. Now this circuit board's actually through-hole plated, which is good. The one thing that Mesa got right on well, I think from the Mark III series onward, is they actually did use through-hole plated boards. Just would have been nice if they were laid out logically and they had some actual pads instead of just tubes. Comparatively, this circuit board, both circuit boards are way better than anything that came after it. Not sure what happened there, but all of a sudden their patterns changed and all the pads became microscopic. Alright, so we're putting some new tube amp doctors in, 220 microfarad, 350 volts. There's 2 holes here for each cap. I guess back in the day the caps were a lot larger diameter for the value, so they probably had multiple sources and allowed for either one depending on availability, which is actually a pretty good thing to do. Even today, you never quite know who's going to be in and out of stock. Just to touch the silicon on the bottom to secure them. I've check the diameter and we can fit in the inner holes, that's fine. I fold them over at about 45 degrees. I don't go the full 90 because then the next person can get their desolder gun in there a bit easier if they use one. Now, these are in series, so we want to have them going opposite directions with the ground over here and positive over here. Okie dokie, solder them in. Really fiddly little board. I should have probably secured it better before working on it because it looks really fiddly in the video, and it kind of is. It takes just as long to find something to secure it and it does to just juggle it while I'm working on it. Alright, so the caps are installed, silicon down, their new balance resistors there. I'm going to get rid of this braid because I don't like the idea of this being around the high voltage stuff at all. Like, it would, you know, granted it would take a bit of effort to get that to go over and touch that, but that's your AC coming from the HT windings. I just don't want loose, uninsulated ground wire pretty much anywhere in the amp. It's just super stupid, and I don't know why they do it. It lets go a little whiskers. You can see one starting to fray off there. I believe they still even do it to this day. I don't know. These guys, they don't think, they just do. And because they've always done, they keep doing, you know. It's just, why would you do it? Just use a bit of hookup wire, champ. Like, serious. Right, next I'll prepare to remove all the pots from the front panel and just flip the main board up. So we'll remove all the knobs and hopefully not pull any pot shafts out in the process. These are very tight. Whoa, that one's tight because it's got a lock screw, grub screw. That one didn't. That's why I was on another planet. Obviously all the pull pots will have a set screw, which is all but one. Every single pot you can pull out. Option paralysis, except for the reverb, which isn't working anyway. Get all these valves out of here and inspect the sockets. They all feel pretty tight, which is good. Check the output sockets for any evidence of arcing or corrosion, anything like that. That one's got a broken off center pin, which is quite common. I'll just be cognizant of that when we put it back in, because now that valve will be able to be put back in at any angle. Alright, the sockets look alright except for that one that broke off the center pin. We'll give the socket, we'll give the contacts a clean and retension. Likewise for the preamp ones, are all pretty tight. Now champions, we all like to laugh about Mesa Boogie and stuff, just mainly because they don't seem to learn from their mistakes, but at the end of the day, they ended up getting bought out anyway, so he got away with his pound of flesh. And they're not that bad to work on. Like, us techs like to whinge about them, but it's sort of just a learned behaviour. If you know what to charge for them, it's billable hours, whatever, eh? It could be working on this or three other amps, so I just charge what the 3 other amps cost, because that's about the same amount of time. Alright, we're down to a 10mm socket for the replacement ones, which are barely finger tight. That's another giveaway that they're not original or even suitable. Yeah, so they've got two washers. One's probably the one that came with the pot, and one's a little bit larger. But you can see how dished they are. That's because they've used a tiny bushing pot on a 3/8 bushing hole. So wrong type of pot. My god, man, that's tight. That's a foot switch. Yeah, bastard. It's better. So yeah, those pull pots, we really should replace them because they're just not mechanically suitable. They're also PCB terminal pots, which isn't great. You can use them in a pinch if you fold the lead around the PCB pin, which hasn't taken place here from the previous person. But I would like to see some original style pots in this unit. So I'll take the reverb pot out because it wasn't connected to ground like it should have been because of the weird mod that didn't make any sense. I'll put that in the to be used later thing, and we'll look at what's involved in lifting this board up. What do we have to remove, desolder, what can remain intact. Generally anything that connects down this end can remain intact, and disconnect whatever is connected up here around this EQ area and the switches on the front panel. Whatever we need to do to be able to flip it upwards and rotate around the axis of this sort of loom here.